formula today, guys. Just gonna make sure I'm recording. Yes, I am. So with the quadratic formula, like I gave you a bit of a question, the graph of this touches the x-axis. What are the possible values of k? Try that one first. If you can't try that, we will come back and we'll review this at the end and see if you can actually answer that. Really, probably the summary notes that you need today in a compressed form would be this diagram, which comes from Cambridge. I think it's pretty good. It explains everything. In the end, we'll come back and we'll look at that. What we're looking at today is really to understand two things: the quadratic formula, how to use it, what it is. I'm not going to talk about how it's derived. I really just want you to understand how we use it to start off with. We'll look at how to derive, possibly another lesson. And we're going to also look at this thing called the discriminant. And discriminant is actually lives under the square root sign. Discriminant is another formula. It's b squared minus 4ac. This is the quadratic formula. You should have this written down into your reference books and your notes. Really, you should actually know it off the end. What does the quadratic formula do? It tells us where the x-intercepts are, or we can solve it, using the null, sort of like the null factor law as well, like how we do that. So it will give me an answer. So when we factorize and we do things like that, I could use the quadratic formula instead. What do these values represent? Well, b represents when we've got an expanded term, y equals ax squared plus bx plus c. When you collect all your like terms and you've expanded it, the pronumeral in front of x squared is a, the pronumeral in front of x is b, and the one without an x is c. Sometimes you may have like no x's, so that would just have a value of 0. You can use this to always find the x-intercepts if they exist. The discriminant will tell us whether or not there is any x-intercepts, and that's what we'll unpack a bit later. So let's run through an example of this. So we've looked at, completing the square, we've looked at factorizing and how to find all these points. Let's do one that we know. Let's go with x squared plus 5, let's go with 5x plus 6. Now, if you saw this, I probably wouldn't use the quadratic formula to find out the x-intercepts. I would just factorize it, right? I would just go, okay, that's going to be x by x, and product of 6 add together to give me 5 has to be plus 3 plus 2. That's going to give me 5x, it's going to give me 6, and so on. Therefore, using the null factor law, I know x equals -3 and -2. So the x-intercepts, so I've solved it for x, therefore my x-intercepts are -3, 0, and -2, 0. So this is what we've done last lesson. And I know the axis of symmetry to find my turning point is -3 plus -2 divided by 2, -2.5, which makes sense because it's halfway between those. Or alternatively, we did the other one, which I already introduced to you, which is -b on 2a. So if we look at -b, so it's -5 on 2 times 1. And that's what? Which is -5 on 2 times 1, which equals -2.5. So I know that's where the axis of symmetry is. So therefore, turning point is at like 2.5 something. Okay? That's where we are. So I substitute 2.5 into the equation. I can substitute into there or there. It doesn't matter. I'll probably substitute into there because it's a bit easier. That would be -2.5, I should say too. That's going to give me 0.5, which is a half. And that's going to give me -1/2, right? That's going to give me -1/4. So therefore, my turning point is -2.5, -0.25. I'll just write it in fractions, because I already wrote in fractions. I probably should, sorry, in decimals. I could have written that in fraction. So then I can draw that from all that, okay? Because we've got y-intercepts. So we've got our turning point, we've got our x-intercepts, and we also know the y-intercept is 6, okay? And so I know from here, where am I going to put that? Okay, so we've got all that. Okay, that's basically what you can do. Now we're going to look at the same example, but using the quadratic formula. I'm just showing you this to show you it gives you the same answer, and it's another way you can go about it. When I would use the quadratic formula is when I can't easily factorize it, or it looks too hard to complete the square. You can always do completing the square to figure out where the graph is. This will always tell me whether or not it's going to have any x-intercepts as well. But let's have a look at how the quadratic formula works. So we've just looked at how we factorized it before. We're going to use exactly the same equation. So I'm going to sort of step it out and put a few more steps in than what I normally would. And later on, you'll sort of see where we go. So the first thing is I've really got to substitute each of these values in there into the quadratic formula. I'm just going to write down the values to show you what they are. So A equals 1, okay, because that's the pronumeral in front of x squared. B equals 5, because that's the number in front of the x. And C equals 6, because that's the number that doesn't have x attached to it. So that's how I get these numbers. Then all you got to do once you got these is literally just substitute into there and solve it. So I'm going to write out the quadratic formula, and this will tell me where the x-intercepts are, okay? So it's going to be negative b, so it's negative 5, and you've got to be careful because it's actually positive 5. If that's a negative, you've got to do it. So I typically tend to put that one in brackets because it's a negative. Okay, then I've got plus or minus the square root of b squared. Again, I tend to put this in brackets as well because if it's negative, I know it's always going to come out positive. This number's always going to be positive because if it's a negative number and you square it, it's positive. If it's a positive number and you square it, it's positive. Minus, then I tend to do this in brackets because sometimes you have a negative in there. 4 times 1, because that's the value of A, times the value of C, which is 6. Okay, that is my square root. And that is all over 2A, which is just 2 times 1. Then we just go on. X equals negative 5 plus or minus the square root of 25 minus 4 times 1 times 6, 4 times 6, 4 times 1 is 4, 4 times 6 is 24, over 2. X equals negative 5 plus or minus the square root of 1 over 2. Square root of 1 is 1. X equals negative 5 plus or minus 1 over 2. Therefore, x equals negative 5 plus 1. So you can kind of separate it over 2. And it also equals, under a comma, negative 5 minus 1, 1, 2. So what is that? Well, negative 5 plus 1 on 2, x equals negative 2, because that's going to be like negative 4 divided by 2. This is going to be negative 6 divided by 2, negative 3. So you can see I got to the same answers, negative 3 and negative 2. So it actually tells you where the x-intercepts are. All right. Then to find your axis of symmetry, we do exactly the same thing. Oh, so therefore, let me, sorry, just don't copy that down. Yeah, also doing really well there too. So it's just, it's great, this formula. It just tells you where it is. It makes everything easier. It's like, why did I learn factorizing? Why didn't I just do this? Start off with, because factorizing can sometimes be a bit quicker. Therefore, the x-intercepts are -2, 0, and -3, 0. Okay, so that's where they are. It tells you where they are. I could, from here, then put it back into factor form, so it'd have to be x plus 2, x plus 3. So then, to find your turning point, I use this method, the same method as before. B on 2a, it tells me where the axis of symmetry is, substitute that into the equation, and you get what it is, except you're going to have to substitute it into this equation at the top. So it'd be like a half squared plus 5 times a half plus 6, and that would tell you what it is. It's negative 2.5 squared. So then you substitute that into the equation, okay? That is how the quadratic formula works. Literally, you just put the values in. Not too hard, I hope. The thing that you've got to realize with it is when it doesn't come out as the exact number, you've got to kind of use the square root to figure out where it is. And we'll run through a couple of these examples for you. Can I move on? Do you need me to slow down? Please yell out if I do, otherwise I'm just going to move on. All right, so let's use this. Let's go with something that's a bit trickier. I'm just going to go into Desmos and we'll make one up. Y equals 3x squared minus 4x plus 5. No. Okay, so you try and factorize that. All right, that one's going to be a bit trickier. 3x squared minus 4x squared. So you might be asking graph or a few different things that you could be asked here. Oh, that one's probably a bit trickier. Let's just change this to 5. No, 6 is what I want, I think. Yep. So I might ask graph y equals 3x squared minus 6x minus 2. Okay, I'm going to say first thing, you always take out your common factors. Is there any common factors in here? Oh, 3 is common. No, it's not. You got two options. And I'm thinking, okay, I could think of, okay, second thing, try and factorize. Okay, so what approach? To find x-intercepts. Could you factorize? If I think of factorizing, I'm seeing it as 3 times 2 is -6. So I want a product of -6 and a sum of -6. I can't think of anything that does that. Like you're going to have, you've got like, I mean, how can you have a sum of -6 and 6? So like you've got 6 and 1. But if you add those together, one's negative, one's positive, it's going to hit the sum. So that would be the product. The sum would be -5. Then I could have -3 and 2, but the sum of that would be like -1. So I can't factorize. You now have two choices. You can either complete the square which will always work for you, or quadratic formula. And that's pretty much how we do it. So that's what I do, is I'll always look at it and go, let me take out the common factors. Once I've done that, can I factorize it? This is too hard. You know what I mean? I can't find anything that works because I was trying to split the term in the middle, but I can't find that. Okay, this is not easy. So I can either complete the square or put in the quadratic formula to find the x-intercepts. I already know what the y-intercept is, right? The y-intercept is obviously going to be -2. So I'm going to use the quadratic formula for this time. So I'm just going to rewrite this equation. So it's, and you could do completing the square if you want. So some people are probably thinking, well, why isn't it complete the square? You can, but as I'm trying to show you that there's a few different ways to go about, doing this. So we have y equals 3x squared minus 6x minus 2. I'll just double check that I've transposed that correctly. Yes, I have. So the quadratic formula is minus b plus or minus the square root of the discriminant, which is b squared minus 4ac on 2a, and that is what x equals. So many people forget that it's actually x equals. And really, I should write x equals all the way down. So I'm now just going to write x equals. This is why I put b in brackets, because it's negative b, okay? So some people make that mistake, which actually turns it then into +6. When you get better at it, you can probably just go, oh, it's -6, so that's going to make it actually +6. Plus or minus b squared then would be 36, because I know that's always going to be positive. But I tend to always put this second one always in brackets anyway. So b squared would be -6 squared. And then I do minus, and then I do a bracket again, and I go 4 times 3, because that's a, right? Because it's 4 times a times c, and c is -2. So if you're not sure, a equals the number in front of x squared, b equals the number in front of x, that's -6, and c is a constant term. So they're just the numbers I'm substituting into here, and I solve. Now, because c is -2, I actually do another bracket. And this is why I tend to do this and leave the negative on the outside, because sometimes you've got like negative, and then actually makes it positive, which is negative, and sometimes it's negative, which is going to make it positive. And I just like to slow it down. I make a mistake here often. This is what I've introduced because I make no mistake. If you don't ever make that mistake, fine. But if you do, slow it down a bit. And that's half the thing with math is just, especially with those tests, is just finding strategies that work for you to really make you get that correct answer at the end of the day. So then I know it's minus 4 times 3 is 12 times 2 is 24, but I know it's going to be -24. Again, I leave that in brackets. That's just the working I tend to do. So I tend to just sort of do it almost like this. So I'll go 4ac, so I'll go 4 times 3 is 12 times 2 is -24. So I write as -24, so I do minus, because I always stuff it up. I don't know why, it's like I shouldn't, but hey, I don't stuff it up anymore because I've got some good strategy in place. So now I know that's going to be x equals 6 plus or minus the square root of, this is going to be 36 plus 24, so that's going to make it 40, 50, 60, right? 60 on 6. Hurrah! A lot of people here may cancel out these 6s, but you can't. You can't cancel out the 6 because that's kind of like saying 4 plus 2 on 4. Oh, cancel out the 4s. Well, it's not 2 because 4 plus 2 on 4 is actually 6 on 4, which is 1.5. Because it's plus or minus, you can't cancel out the 6. If you get a 6 both out there, then you can. So just be wary of that you can't cancel it out. Okay, so all we've done, guys, just to quickly recap before I get any bit more into surds, is if you get an equation, okay, you will get an equation that will say use a quadratic formula to graph it or to find x-intercepts or to solve it. If I'm saying solve it, it's just what does x equal? So you always want to, if it's just graphing it, okay, if it's just saying you have to use a quadratic formula, just go straight to this step. But when I look at questions, I kind of say, oh, how am I going to approach this? I kind of go, well, let me take out the common factor first. And then can I factorize it? No, that's too hard. Okay, I can complete the square quadratic formula. Today I feel like doing the quadratic formula. Then we literally just, it needs to be an expanded form. A is the number in front of x squared, B is the number in front of x, C is the constant term. You just substitute those values in there. Be careful of your negatives. So many people stuff those negatives up, okay? So I tend to personally just substitute everything in, put that negative here, put the negative on the outside, that also in there. Just slow it down a bit because I make a lot of mistakes between here and here. So from here to here, I just stuff it up. So just be aware of that. Now, all I need to do is x equals 6 plus or minus. I'm thinking of what can I actually simplify this as? 60. Okay, so do I have any, like 4 will give me 60? 4 times will 9 be able to go into it? No. Would 16? No. Would 25? No. Okay, so I'm pretty much 36 now. I'm already tapped out. So 4 would be in there. So it would actually be, I'll just slow it down again just to remind you about surds. It's going to be 4 times 10 would give me 40 times 15. Okay, on 6. Now remember, I can take out that square root of 4 because it's a perfect number now. And this is why we did surds. That's going to be 2 root 15. Okay, now this is simplified. Okay, this is the number that I'm going to use on my graph. But what is this approximately equal to? Because if I just give you a graph and I'm like, hey, sketch it, you're going to be like, well, can you guys tell me what 6 plus or minus 2 root 15 on 6 is off the top of your head? Probably not. So I come back up to this step, okay, and I can actually see that this is approximately equal to 6 plus or minus. Square root of 60 is between, what do we got? We've got 25, 36, 7 7 is 49, 8 8 is 64. So it's probably like, I don't know, 7.8, right? On 6. Yeah. So I can see that therefore what the value of this is it's approximately, so I go back up to this one because this one just doesn't make much sense. It's a lot easier for me to do it up here. So that's approximately, if you think about it, that's going to be like negative 1.8 divided by 6. So that would be like, I don't know, negative maybe 0.2. And what else would it be? It would be like 6 plus 7.8. So that'd be like maybe 2.2. You know what I mean? Positive. So I've got an approximate answer of where I can graph those. So then if you're given a graph, you know, and it had like, you know, negative 5, negative 4, negative 3, negative 2, negative 1. Whoops, did that really bad. So that's negative 5, negative 4, negative 3. I know it has to go here and 1, 2, 3. I also know it needs to go there, okay? Because it's like, that's 2.2 and that's negative 0.2. So I can actually figure out where the value of these are. And that's probably the tricky part of graphing these. So I am going a bit beyond what you do, but I just want to give you more the concepts of that from the start. So I know that that is approximately, from this step, negative 0.2 and 2.2, okay? But that's my x-coordinates. Therefore, x-intercepts are at 0. Sorry, not 0. Are at if you think about it, it's if you've got a number and you minus it away, that's always going to be the lower first one. So that would be 6 minus 2 root 15 on 6. Oh, by the way, I haven't fully simplified this. I just realized. Okay, because I can now divide both of these and that by 2, that's going to leave me with 3, 3, and that. So therefore, it'll be, I know the x-intercepts are 3 plus or minus root 15 on 3, comma 0. Oops, minus. It should be minus because that would be the first section. And that's actually a lot easier to solve. I should have simplified it from here, but I didn't do that right. And it is also 3 plus root 15 on 2. Root 15 is going to be, what, about 3-ish? Bit between 3 and 4, probably closer to 4. So it's going to be like 7 on 2. 7 on 2 is 3.5. How did I stuff that up? I must have stuffed that up. Did I stuff that up here? 3 plus root 15. Root 15 is 3, yeah, 3 point something. So that's going to be 6. That's going to be 3 point, something, not 2 point something. And this is going to be 3 minus 3 point something, which is divided by 3, which is going to be pretty much like that. So I'll stuff this up. Did I stuff this up? 6 plus or minus root 60 is going to be 7.8. So that's going to be like 12. Sorry, I'm just trying to see what I've done here. That's going to be 2 point something for sure. Yeah. So where did I go wrong? 2 is out. And take out a common factor of 2, 3, 3, 3, 3. 3 root 15 is going to be it's going to be 3 point something. That is 6 divided by 2, which is 3 point something. Okay, I do not know where I've gone wrong there. Did I simplify my surd? I'm pretty sure I did. I can definitely do that with this surds. It's 3 minus 2. Oh, it's not times. It's a subtraction. But that shouldn't matter because it could be 6 on 6, which is 1. And that's still 1 plus 2 on 6 would be a third. Let me just see something. Sorry, I'm just going to go into my CAS here. We're going to do 6 plus, let's do this, 6 plus, maybe I didn't quite do something right. I did get 2.29. Oh yeah, that was a pretty good guess though, wasn't it? 2.2 was an educated guess. 2 root 16 on 6 plus 6. Can I not simplify it? I thought I should be able to simplify that. The 2 should cancel out with that. Let's see what this number is with it. Let's go with 3 plus root 15 on 3 is 2.29. Okay, so I have stuffed up that calculation of this one. How do I stuff up the calculation of this one? That's 2.29. That's the same value as the other one. That's good. I thought I was doing something wrong with surds, but no, I have simplified correctly. That's going to be 3. This is going to be like root 15. Let me just do my calculations. It's going to be like approximately 3 plus root 15. Root 9 is 3, right? Yeah, so it's going to be like 3.8 on 2. That's going to be 6.8 on 2. I'm wrong here. Oh, it's on 3. I'm doing it on 2 in my head. I wrote it as 2. It's meant to be 3. Come on, guys. Where was it? Transcription error. Oh, no wonder. Oh, silly me. It's on 3. That's why I was getting so confused. I'm like, it should work out. 3 plus 3.8 on 3, which makes 6.8 on 3. That makes more sense, which is about 2.3-ish. So that's good. I'm happy with that now. Oh, geez, that was annoying. All right. Feel free if you saw that to let me always know. 0. Okay, good. There we go. So that would be the fully simplified down version. And now I know where they are. I know where my x-intercepts are, and so on. So then to find the turning point, I know that I can find axis of symmetry equals negative b on 2a. So negative b is negative 6, so it's actually going to be 6. Let's do it slowly. Negative 6 on 2 times a on 2 times 3. So that's going to actually be 6 on 6, right? So therefore, x will equal 1. Okay, so to find my y-intercept of that, I can then substitute in x equals 1 into the equation. It's going to be 3 minus 6 is negative 3 minus 2 is negative 5. And that is my turning point. And now we have all the information that we need. Y-intercept is -2. And we've got everything else. So you'd come to the equation and you'd actually find, see that's the value there, all of these, -5, 1, you know, that's approximately 2.2, but you wouldn't write that as that. You would actually write that as this simplified fraction. So it'd be 3 plus the square root of 15 on 3. That's what you'd write as intercept there. And that would be 3 minus the square root of 15 on 3, 0. And you've got all your graph, and you can draw that. And because I know approximately where it is, I can graph that accurately. And that's it, pretty much with those ones. So that's how we use the quadratic formula. Yeah, definitely felt like that moment there. Did not transcript correctly. Have you guys got any other questions for me at all regarding the quadratic formula and how we go before I move on? So how we use this quadratic formula. Again, I'm just showing you how to use it. Can you guys give me a bit of feedback, 0 to 5, about how comfortable, if I threw you guys an equation, you'd be able to then tell me what the x-intercepts are. You could just plug in the numbers into this and solve. 5 being easy peasy, 4 being, I'll probably want some practice to just double check. 3, bit unsure, 50-50 either way. 2, I reckon I still need a bit of help with that. 1, I would be lucky if I got a couple right. 0, I would have no idea how to do it. Please give me that bit of feedback, and then I'm going to move on to the discriminant after that and show you guys how the discriminant works, okay? Yeah, and I will save these notes and put them up on the resources as well. I'm going to move on to the next equation. If you can please give me feedback, don't just sit there quietly. I know you guys are good at sitting there quietly. Oh, what's going on here? Okay, when I go back and check, you guys have all given me feedback. And if you've got any questions, now would be a really good time to ask them before I move on, because I'm going to leave the quadratic formula there and go on to the discriminant. On 3. Any questions at all? Please let me know. 453, thank you. All right, okay, I feel pretty good at that. So you will get some time to work through this anyway, hopefully this lesson, if not next. I'm going to show you guys this question here, okay? We're going to basically have a look at this. This is exactly the same one we've done, but I'm going to look at the discriminant. So what is the discriminant? The discriminant is in part of the quadratic formula. So if you write down quadratic formula for me, that is it, okay? Discriminant equals b squared minus 4ac. That's what the discriminant is. So that is the discriminant. It lives under the square root of the quadratic formula. I want you to stop and have a think about this, okay? If I get a number here, right, and it's a positive number, where's Costa? Costa, you there? Put your mic on for me.
Yeah.
Costa, if I get a positive number in here, can I square root a positive number?
Yeah.
What sort of answer would I get? Give me an example of a number that I could square root.
36.
Okay, so if I go negative b plus or minus the square root of 36 on a, I'm going to get 2a. I'm going to get how many answers for what x equals? Don't forget this is what x equals. So that is x equals. So
2.
Why would I get 2?
I don't really know.
Okay, well, you're right. Why would you get 2? Why did you think that? What's your first answer going to look like?
B plus 6 root 6 there, plus or minus 6 root
So
6.
this would be, what's the square root of 36?
6.
Right, so it's going to be plus or minus
6.
6 on 2a, right?
Mm-hmm.
Because we're just looking at discriminant now. I don't care about anything else. Then what would your answers for x be? You're going to have 2. Where are the 2 answers? Do you want me to go back up to the other example to help you out?
Oh, yes, please.
Yeah. How do I get 2 answers for this?
So I go back down.
Yep.
Would it be negative b plus 6 over 2a?
Right, yep.
And then negative b minus 6 over 2a?
Right. There's your 2 answers. These are going to give you 2 different spots on the graph, aren't they? Because one's plus 6 and one's minus 6. Can you see that?
Yep.
Or solutions. Oh, okay. How would you just get one answer? If I just wanted one answer, x equals negative b plus or minus the square root of something on 2a. If I just want this one answer or the same answer twice, what would I have to square root? What does this need to be? Costa, you there?
Yeah, can you just repeat that?
Okay, let me ask you a question. Why did I get... I'll ask you the question. If you don't know, I'll help you get there, okay?
Okay.
So what I'm trying to ask is, what would I need to add and plus here to just get one answer? Like the same thing? Because we've got 2 answers here, but how would I get the same answer twice?
Would it be something that can't be square rooted?
Okay, maybe. Let's try it. What can't be square root?
Just go 37.
I can square root 37.
Oh, yeah,
That still gives me an answer, doesn't it? It's like 6 point something. So if it's 6 point something, am I still going to get 2 answers?
Yep.
Yep, I
am. Fraction?
A fraction? Can I square root
Yeah, you're right. Yeah.
4 on 16? I can. That would be 1 on 4, right? That'll be positive or minus possibly. Anyway, yep, that'll be a quarter. Yep. Good one.
I'm not really sure.
Okay, let's think about a number line. So far on a number line, you gave us 6, which is root 36. We also said root 37, which is just root 37. You can actually square root that, right? And then you said a fraction, so it would be like right down here. I don't know. Let's just go with, if it was 1 on 4, you can square root that. That would be, square root of 1 on 4 would be a half.
Wait, so would it be a negative number?
Okay, if it's a negative number, what happens? Let's have a look at that. Let's try. So let's try what? Negative 36?
All right.
Because that's, what is the square root of negative 36?
Can you square root negative numbers?
So let's say it was negative 6. What would the square root be?
Can you square root negative numbers?
I don't know. If it's negative 36, what would it be? What 2 numbers would you think would have to be it?
6 and negative 6.
Right. And what do you know about square rooting?
You're splitting up a number.
Right. But what's the answer? So why is the square root of 36 6?
Because if you square 6, it's 36.
Yep. Okay. So if you square
which
6,
is
it's
times
36.
itself.
Yep. So it has to be times itself. So what do I square here? 6 or negative 6? If you take negative 6 and you square it, what does that equal?
36.
Right. So when we're square rooting, we're looking for two numbers that are the same, aren't we?
Yep.
Are these numbers the same?
No.
So can I square root it?
No.
Okay. Let's try. So what do you think is going to happen if I have a negative number in here?
You won't be able to square root it. So you only have one answer.
Will I have one answer? I can't solve it.
Well, there'll be no answers.
So x equals negative b plus or minus the square root of negative 36 onto a. There's no real solutions.
Yep.
Do you want to know what that means?
Yeah, go on.
So the graph, therefore, there's no x-intercepts. So does that mean the graph still exists?
No.
It would still exist. It just means if it's positive, it's going to have a turning point above there, or if it's a negative graph, it's going to be a turning point below the x-axis.
Yep.
Does that make sense?
Yeah,
So
that makes sense.
if I do my quadratic formula and I get this negative value of the discriminant, which sits under there, so I can just test out the discriminant and do 4ac. And if it's a negative value, I know that I can't actually do the quadratic formula to solve it, or graph it, I should say. Therefore, the only option I have then is to complete the square, because that will show us how it's transformed and where it's moved to. Does that make sense? Because I don't have any x-intercepts. I hope that makes sense. If not, work with me. Okay, so my question to you then is, we've looked at two situations. Let's look at the next one. What other values? Have we got everything? So we've done negative b plus or minus the square root of positive numbers on 2a. Would you get a solution for that?
No.
If it's a positive number under the square root?
Yeah.
Yep. And how many solutions would I get?
2 or more?
Right. 2 or more, or 2 or more, or 3 or 4 or 5?
2.
Why 2?
Because that's what we got on the last one when it was positive.
Yeah, because 1, so this term plus or minus means you take this and you add that, and you take this and you minus that. So you're only going to get 2 terms. It's not like plus, minus, divide, and multiply all in one. You don't do that anyway, but do you know what I mean? That's why you're only going to get 2, because you go this plus that, this minus that, and obviously both of them divided by that. So you're going to get 2 solutions. If we have the discriminant, and so we're just looking at what falls under the square root sign. So this is a quadratic formula, and we get a negative number. Can I solve that?
No.
No. So I actually have no solutions. Does that make sense?
Yep.
Right. Let me ask you this. I'm going to give you the next one because you worked through that so well. If I plus or minus the square root of 0, how many solutions do you think I'm going to have? Now have a think about this before you just go answering it. And everyone else have a think as well. How many solutions do you think you would have? How are you going, Costa? Tell me what you're thinking. What are you thinking? Tell me what's going through your mind. Don't worry.
I think one solution because it's something that's like something plus 0 and minus 0, so it's the same thing.
Spot on. That's exactly what it is. Because if you think about it, isn't it just going to be minus b plus or minus 0? So that's the same thing on 2a. That's what it simplifies to, right?
Yeah, pretty much.
So that's why. So it's one solution as that's what it's going to be. And what's this? That's how we find our symmetry of axis, which is interlinked, but I'm not going to get into that. So what have we realized? Our discriminant tells us a few things. Our discriminant is b squared minus 4ac. I don't always go straight to the quadratic formula. I'll calculate the discriminant first. If the discriminant is greater than 0, I know it will have two solutions. And I can continue on using the quadratic formula because I know I'm going to get an answer. If the discriminant equals 0, I can use it. I'm going to get one solution, and that means it will actually have a turning point on the x-axis. So this would be a graph like this. This would be a graph like the turning point on the axis. Now, it could be negative as well. And if I do the discriminant and I find that the discriminant is less than 0, there is no real solutions. Now, why I say there's no real solutions, because later on we learn how to do that in specialist maths, deal with negative numbers, but not in methods. No real solutions, therefore no intercepts. Okay, so that could look like this, right? The graph still exists, but it just doesn't have x-intercepts. So that's where the discriminant is really, really cool, okay? So to have one solution, the discriminant needs to equal 0. So when I looked at this graph here, when we did this one before, if you look at just doing the discriminant, b squared minus 4ac, so you could just go, okay, that's going to be 36 minus 4 times 3 is 12 times that is going to be negative 24. Negative 24 is 24. So it's going to be 36 plus 24. It's the square root of 60. I know I'm going to have two solutions because it's going to be minus b plus or minus the square root of 60 on 6. There has to be two solutions. I have intercepts. Let's throw you guys in the deep end. Let's try this question. So that is the discriminant, and that's what the discriminant tells us about how many solutions there are. So the graph of y equals 2x minus kx plus 3 touches the x-axis. I'll give you guys a bit of a hint. If it touches the x-axis, how many solutions will it have? What do you think, Costa?
None.
So if it just touches here, it will have one solution.
One.
Okay, because it touches the x-axis. So this is a year 11 one, so I'm just sort of scaffolding you. So I know, therefore, the discriminant must equal what? And we use the triangle for discriminant. What does my discriminant need to equal if it has one solution? It must equal 0, right? Are you with me, Costa?
Yep.
Because it needs to be 0 to have one solution. So what is my discriminant? Well, my discriminant is b squared minus 4ac must equal 0. Now, this is, as said, going a bit further. I'm just going to run through this and then we're going to go back to something a bit easier. What is b squared? Well, b in this form is actually k. So that's going to be k squared minus 4 times 2 times 3 has to equal 0. So that is k squared minus 8 times 3, 8, 16, 24 equals 0. So k squared equals 24. Therefore, the value of k must be plus or minus the square root of 24. And I can simplify that, which means k will equal plus or minus 4 comes out of that, which would be 4 times 6, which would be 2 root 6. So that would be my answer. So the possible values of k would be plus or minus 2 root 6, because I know that because it touches the x-axis, the discriminant needs to equal 0. Therefore, this needs to equal 0. Substitute all my values and I get that. Now, don't worry. I know that's probably just blowing your mind and you're like, what is he talking about? But let's go back to something a bit easier and we'll wind up the lesson. So I'm just going to go back to what we talked about so far. So we have the quadratic formula, which tells us where the x-intercepts are. Just trying to make it really easy. So just sort of almost refresh your mind, forget everything I've talked about, but then try and bring it back. So we've got this will tell us my x-intercepts. The discriminant lives under here, which is 4b squared minus 4ac. If this has a positive value, well, you're going to get two solutions because you can square root a positive number. If this is 0, well, the square root of 0 is 0. So if you're plus or minusing 0, you just get the same answer twice, which means you just get one x-intercept, which means it just touches on it. If this is negative, you can't actually solve it, so you've got no solutions. And that's what I'm trying to show you. So it's quite easy to use a quadratic formula. I understand the discriminant is a little bit more difficult, okay? So let's find the discriminant for this. Let's just do a really easy one. And then we'll finish it up. And tomorrow we'll just be working on this for the class tomorrow or next lesson anyway. Give me a letter from I to L. We'll just go with L. Let's go with L. Let's go with the last one. So let's go with y equals negative 5x squared plus x. Let's find the discriminant for that. Okay. Oh, that'd be right. I've got to move this on the next page. So the discriminant, if you think about it, is really my discriminant is this part that sits under the quadratic formula. So it's b squared minus 4ac. Okay. So let's see. The value for a equals negative 5. The value for b equals 1. And the value for c equals 0 because it's not there. So I'm going to substitute that in. B squared is 1 whole squared minus, I like to do brackets, 4 times a, which is, what's a? Negative 5 times c. Now c is not there. Do I substitute in 0 or not? Yeah, you do. So that's just going to make that 0, right? So my discriminant actually equals 1. Will I have a solution? Yes, I will. We could actually go on to graph it. I'm not doing that because that would be my final answer. The discriminant equals 1. But if you did want to just graph it, find out my x-intercepts, it's negative b plus or minus the square root of 1, because I've already figured that out, on 2a, 2 times negative 5. So, whoops, I've kind of put, let's just write 2a. Sorry, that should be on. And then that would be the substitute your values in. So that's going to be b equals negative 1 plus or minus 1 on 2 times negative 5, which is going to be negative 10. So x will equal negative 1 plus 1 is 0. So that is 0. And negative 1 minus 1 is negative 2. Negative 2 on negative 10 is going to be 2/5. Is going to be 1/5. So I've solved my x values. If I wanted to find out the intercepts, 0, 0, 5th, 0. And that is it for you guys. So that's how we find the discriminant, and it helps us to do that. So as I said, the easiest things for you guys to do today, and what I really wanted you to do was, and it is a pretty complicated one, but at the end of the day, it's just sort of using those formulas. We will do it. Please don't crash on me, Word. Okay. The main thing that I said at the start of the lesson is that this is your compressed notes. Let's just look at this again. In the quadratic formula, we've already talked about how this will find our axis of symmetry, okay? And you substitute, you find out what the value is at, substitute it into this equation, and you'll find out what the y coordinate is. We can see here the value of c, right, is the y-intercept, which makes sense, okay? Here is b minus the square root of b squared minus 4ac. Obviously, if you take away a number, it's going to be more negative, so it will be to the left, the graph, Doesn't have to necessarily be on a negative plane, but it'll be the left side of the graph. Whereas if we're adding that number, you're going to get another solution. So the discriminant needs to be positive, because then you're going to get two solutions. If the discriminant's negative, you're adding or subtracting 0, and the turning point's just going to be on the graph, right? And if it's a negative number, well, it's going to be way above. So this is a bit of a compressed graph about how it uses the two things that we sort of looked at today. It was really looking at the quadratic formula, but also looking at, why we get two solutions. This has to be positive, or we get no solutions, or we get one solution because it's 0, so it's the same thing, or we get none. So that's kind of where I want to go through with you guys today on that, and that's sort of where it shows how we get there. So let's go to just when you're having a look through the book. As I said, you'll be going through it and reading through that. So when we're going through this book, guys, have a read through this. This is basically the quadratic formula. It's in this form. The discriminant is what we've talked about. It determines the number of solutions. If the discriminant equals 0, and notice it's a bit bolder on the sides, therefore it will just have one x-intercept, because the solutions become just minus b on 2a. That's what the solution is. If the discriminant's greater than 0, that means it's positive. We can actually square root that. We're going to have two solutions. If the discriminant's less than 0, well, you can't square root a negative number. Well, you can. You don't get a real solution. Therefore, it's either going to be a positive graph with the turning point here, or it's going to be a negative graph and the turning point is going to be below the x-intercepts. This is where I got the key idea from, okay? When we're looking at some of the examples, you can watch the videos for those as well. Consider the parabola given by the quadratic equation. Determine the number of x-intercepts. Well, okay, to determine the number of x-intercepts, I can just test out the discriminant, because the discriminant, if it's positive, I've got 2. If it's 0, I've got 1. If the discriminant equals negative number, I've got none. So we just put it into this formula. It says negative 24. Because it's negative, there are no solutions. There's no x-intercepts. There's no solutions. So you might be like, determine the number of x-intercepts or the number of solutions. I use those interchangeably. When it's solutions, this would have to just equal 0, okay? So I do use that interchangeably. The y-intercept, well, 5, okay? And then use that to determine the turning point. And we've kind of done that previous lesson. So again, substitute it in. It tells me that the x-coordinate is 1. Substitute 1 into the original equation. The y-coordinate will be 2, so therefore it's at 1, 2. Sketching graphs using the quadratic formula. So if we want to sketch this, okay, I'd go, okay, 2 times 3 is negative 6. Negative 6 sum of 4. That would be, I can't do that, right? First I'll be looking at it, can I take a common factors? No. Can I easily factorize this? No. Okay, I could either do the quadratic formula or I could do completing the square. Completing the square will always work. Quadratic formula won't to sketch it, I'm saying. The quadratic formula won't work if it's got a negative discriminant. So because the graph will still exist, but it's just going to be above, the turning point will be above the x-axis or it'll be negative and below it. So, okay, we're going to do anyway the quadratic formula. This is the one we're doing. Label all significant points, x-intercepts, y-intercepts, turning points. Round the x-intercepts to 2 decimal places. So you need to use a CAS. I tend to keep them exact. We know the y-intercept is negative 3. Okay, x-intercepts, I'm going to use the quadratic formula. So we literally have A is 2, B is 4, C is negative 3. A really important step is to actually let it equal 0, which is something that I didn't put in my working, so I do apologize for that. But now I see this, it is a really important step. You need to let that equal 0, because to find the x-intercepts, you have to say y equals 0. And that's actually, I made a big mistake, I've just realized in my working out. You need to let that equal 0, and then you can use the quadratic formula. So I do apologize for not putting that scaffold in there for you guys. Minus b plus or minus square root of the discriminant, which is b squared minus 4ac on 2a. Okay, so you basically put all your numbers in there. Just be careful of your negatives. Then simplify it, rationalize them as much as you can. When you get to this solution, you pretty much, to 2 decimal places, you need to use a calculator. So then you've got your x-intercepts. Okay, you found out roughly where they are. Then to find out where your turning point is, we use minus b on 2a, substitute that in. That will tell us where x is, the symmetry of axis. and then substitute -1 into the original equation, and you can see that's -5. And then finally you have that. Again, don't graph it like this. Graph it with coordinates, as I've always done. Okay, so they should all be in ordered pair, each of these ones there, because that's what we really want you guys to do in your 12 methods. And that's it. So, bit of feedback, which I always really love. I'll stop recording there for you guys.